Hello everyone, welcome to the Golden Skills Profile. This is a data analytics project that I developed with the dual intention of showcasing how text analytics projects get developed and what kind of problems do come up while analyzing the data in the textual form and how those can be resolved while keeping the business objective in mind. Secondly, I wanted to solve a problem. Currently, the skills mentioned by recruiters for a specific job description or the roles mentioned out for a job description are not standardized. There's a quite a title salad out in the market, and everybody is trying to come up with a fancy word. So it becomes very difficult to identify what are the roles that a particular person can relate to or should target. And similarly, what are the different key skills that are in demand for a given role. Now, how did we do this? Before we begin with the actual problem, I want to highlight all projects have to follow certain framework. Well, the most important reason to have a framework in place is so that you have a clear sense of your roles, responsibilities, and expectations. Not only the development team, but the stakeholders as well need to be on the same page as when what can be expected and how the project will move ahead. There are various frameworks available in the market, as mentioned here. We'll just discuss the two of them, PPDAC and CRISP. CRISP is an industry agnostic framework that is mostly used for machine learning and related problems. Whereas PPDAC is most of a research based, we are trying to do a statistical inquiry, identify if a given hypothesis is valid or not. And there are others, but key things you have to remember is everybody in the team should be aware of it, and you pick up the framework that is primarily in line with your organization's working style, your stakeholders working style. Cooperation and teamwork should be the result of using the framework, not otherwise. Now, coming back to what kind of problem we have, let's first define it properly or reframe it as we call it in the systems thinking. If you have to look for a specific job, let's say you are a Java developer, there are over a dozen roles that mention Java developer or the skills of a Java developer. Those could be senior Java developer, Java lead, Spring Boot lead, Spring Boot backend developer, Java backend developer, and so on and so forth. There are two problems because of this. One is you may not be targeting the required role. Secondly, you do not know what is recruiters primarily looking for right now for a given role. Is it Spring Boot framework? Is it microservices? So both of these solutions or problems can be handled by a given solution. Before we proceed, there are two things I want to clarify. One is this is not a NLP problem because we are not going to do kind of topic modeling or not going to work on job descriptions per se. We will work on the specific key skills or essential skills that recruiters specifically mention as part of the job description. We are not going to extract a key skill. from the JD, but utilize the given key skills and see which of them are required and how much priority is to be given to a given skill. Then on the title end, we will be trying to solve the problem like sales manager and area sales manager are basically the same thing. But maybe you are looking for sales manager and area sales manager is not even showing up in your search. There's a possibility. So first look at the data we have. I scrapped 97,000 friend of mine job records for the year 2024. These are actual job records. And we are going to work on titles and skills as the primary data point for analysis. Initially, we simply thought that what I can do is look at what are the user fuzzy matching by counting, you can say, token set ratio. That's one approach. And then figure out the same keywords. Like here, you can see 2 out of 3 and all 2 out of 2 words are matching. So this probably will be able to group it. But upon doing it on the test set, I got to know that this is also combining Java developer and .NET developer, which is absolutely not required. So the reason is we need to identify not the keyword but the meaning of this keyword, whether Java developer has Java as a identifier or is it an extender of the role. So the relationship we see between these is a hierarchical relationship, whereas these are two different types of developers having distinct skills or with a little bit of overlap, but key skills are distinct. Now, how do I identify this? I need to associate meaning with this identifier. Now, simplest way to do that is rather than dealing with this, we cannot do this with using grammar rules as because both of these are nouns. They're not different parts of the word speech, and we do not have a sentence here. All we have is comma separated skills and individual titles. So topic modeling or NLP use is not on the table right now. But to have the meaning you utilizes, we have to have something called as context understanding. One of the simplest ways is to use this small model. It's 80 MBs of size and has 6 layers transformer architecture. Now these are context aware and excellent at handling meaning representation in a vector space. Now this is a very light model and it can be used on edge cases. So if we are going to have an app that is going to have the skill, this is a perfect solution for that. Now this model helps us have vector representations that are able to identify that area sales manager and sales manager are semantically same. Okay. But this didn't solve our problem completely because some of the recruiters had used titles such as hiring for urgent requirement of so and so or Java developer is required at XYZ Limited. Now we are not going to have any standardizations with company names in place. So the first intent is to remove the company name. A simple approach is to use named entity recognition methods and call out organizations or locations, as some of the titles had locations as well, and remove them. But when I try to do it, I hit another roadblock. Now, the Stacy's problem was some of the organization names, nouns, are actually extenders of the job title. Like Microsoft CRM developer is as good as Java developer. Microsoft is an organization name, but in this particular case, it is not a entity, but a essential identifier that I need to keep. Further improving the data, I identified that all the companies that were using this kind of titles were very small companies, not having distinct roles in the first place, and were actually requiring single teams or a group of teams to have multiple hats in the limited people that they have. So, our key interest here is to have standardization rules. So, for us, this was more of a noise, and anywhere we were having a job title with more than 5 words was simply dropped out. Now, after that, we are left with as vectors which have less than 5 names, and now we need to group them together. First approach is to use cosine similarity. It gave a similarity score to each job 0.89, 0.88, 0.878. Now, but this scoring does not help in identifying a key name. I need a group. I need to identify that A and B are together and are different from C, not the similarity between them. I do not need to manually intervene and make a distinct boundary because that will be impacted by my personal bias, or the person doing this may not be up to date with the industry or the latest market trends. So I wanted to figure this out or discover this from the available data rather than put a hard boundary at a given similarity score or a group of similarity values. So the solution seems a very generic solution seems here is a density based approach. Now we converted the similarity of initially I was working with a similarity of greater than 0.85, which I used density based and looked at a distance of less than 0.15. This will automatically group them together into clusters without me identifying either a boundary or the number, because I do not even know how many clusters can be formed over there. So this DV scan seems to be the perfect approach. But it also failed me at a specific scenario where there existed some weak bridges so that the logic can hop from one name to the another. As an example, project manager is very close to project lead, and some of the flat organizations do not use manager as a name, but rather want to work with leads as long as somebody is doing an individual contribution kind of thing. And project lead and lead manager are very, seems same thing, but they are not. These are mostly customer facing roles, just like lead sales manager is a very sales particular manager, but may not be at the group level, but maybe of individual unit or individual subunit kind of thing. Now, because of these weak bridges, our way of doing density based clustering was hopping from one of these and trying to create one role as manager, which definitely we do not need or we do not want. So took some, inspiration from the gradient descent and decided to break this into stepwise. Like we have stepwise learning rate in the gradient descent. So similar thing we tried to do here. First, we reduced similarity under 0.05, the distance under 0.5, and try to create one cluster, one group of clusters. Tier 1, let's call it tier 1. It will have, so say, 100 clusters, and each cluster will have exactly the same role. Like here, tier 1 showcases all names are same. Then extended the distance, but rather than utilizing dbScan over the entire set, we limited its scope only to the set that is remaining in the first iteration. After creating a tier 1 list of clusters, whatever was pending was marked as noise minus one cluster. And now with second iteration of tier 2, with increased distance, performed the db scan only on the noise cluster. This helped us break the bridges and did not allow it to create the muddy clusters. So similarly, increased the distance again and created a tier 3 list of clusters. Now, whatever could not be grouped into clusters was remaining as noise, and the overall noise factor got reduced under 40%. Now, here's the actual data, examples of the actual data. In tier 1, we all have job roles that have exactly same names. Whereas while coming to tier 3, now this 792 is a cluster ID. In tier 3, which shows third iteration, or a given cluster 792 may have different names: Python test engineer, test professional, and Python tester, all clubbed into one cluster 792. And this shows that we discovered this particular group as 792 cluster in our third iteration within the distance between a little above 0.12 and below 0.15. This solved the problem of bridges and helped us have distinguished roles. But having a cluster 792 does not help anybody, at least the person who is trying to look for a job. So we needed to have a name given to that cluster. But again, keeping the human bias out, I do not want to give a name that was human defined, or the first name appearing in the cluster, or any name out of the cluster. To have a real picture of the market trend, I wanted to have a name that represented majority of the people or majority of the roles within that cluster. So weighted mean of the vector of a given cluster, which is essentially a centroid, that helped us. Now, how does it help? What it does is it creates a common name for all different roles. An example here, like supply chain analyst, supply chain business operations analyst, or a supply chain operations analyst, they all were given a standardized name as supply chain operations analyst. Now this is created a new column in the data. And this weighted mean also helps us that if there are 5 roles, 3 with senior Java developer and 2 as just Java developer. So because of the weighted part, this cluster will be named as, with the standardized name will be given as senior Java developer. Now this happens without any human intervention, so we are not getting impacted because of some domain understanding limitations here. Now, how does this help us to generate the insight at the skill level? It does not. All it does is it gives us a list of standardized names for the job titles. Now, next part is to map the skills that are currently mapped against non-standardized roles, and we have a standardized roles here. So we need to map it here. Skills are all comma separated. A simple way is to explode these skills into row wise and then regroup them against standardized roles. So I will have like here supply chain operation analyst, and skills here as analytics, Excel, Power BI, R if they need it, and so on. Now I need to identify whether Excel is the primary skill that is asked or expected of a supply chain operations analyst, or is it Power BI or Tableau? Making a Google search how many companies use Tableau or how many companies use Excel is not of any, in fact, much value here, because you do not know whether supply chain operations analyst is the role within those companies or not. So how do I enhance this clarity here and make this understanding available to the user? That out of all these, most important is Tableau. A very simple heuristic approach here is we look at all the listings of supply chain operations analyst as a standardized name, which includes the different variations of it, and look at how many times or how many job roles ask for Excel as essential skill and how many job roles ask for Tableau as an essential skill. Now, this frequency will tell us whether Tableau is more important for a SEOA or Excel is more important. So here we are, how this is going to help is because we are looking at this specific distribution only for supply chain operations analyst. Maybe for journalism analyst, this skill set could be different. Or a research analyst in an educational institute, this could be different. They may be looking at R as a primary skill rather than Tableau or Python. So our hierarchy of skills will come with respect to a given role. Now, this worked well until we moved it to the production. In production, scalability is the primary concern. Now that vectorization done by our model, it creates a n cross 1 matrix to map out the similarities. We have 90k rows, which essentially creates a 32.GB matrix that needs this much of RAM. Surely this is not going to work in production, or it is going to consume too much of a resource, which makes, if it is deployed on a cloud, this is going to explode my bill, which I do not want. Technically, there are many solutions to this, PCA being one of them. Can this Facebook provided assisted search algorithm that leverages nearest neighbors? This is one of them, but I do not want to increase the code footprint. Sparse matrices is another approach where we can tell that rather than creating an Gaussian matrix, only create it where similarity may be greater than 0.7 or 0.6. We can put a cutoff. We know essentially that anything going beyond below this will definitely not be a required similarity. We are not interested in it. But this approach seems scalable right now Let's say take a scenario where we have tomorrow some batch processing done over this model, and let's say we have 200k rows, or this model is deployed at a global level by Indeed or something, and we have a large data. Then whatever comes under zero point 0.7 or whatever cutoff we place may again need large amounts of space. So there is still a possibility of out of memory, though reduced, but we have not completely eradicated it. Now there's another very simple approach. A lot of times simple things work better. That we can chunk it, the input, and break it down into small batches of a fixed size. Then whether we have 200 KOs or 90 KOs, all we have is a number of batches, which means number of iterations that are passed into the model rather than increasing the load for the consumption of resources. If you break it down into 10K, it only needs 400 MBs of RAM. So it's a considerable improvement. This chunking, blindly doing chunking, will create one more problem. That is, there is a risk of 943 cluster having 12 records, and in one iteration of one chunk, let's say 940 40th chunk, or 940th chunk, you are only sending 7 of them, and next iteration will have another 5. So you are breaking your 943 cluster, which you have created with so much of precision and hard work, unnecessarily. This will lead to poor analysis or poor insights. Then another approach is that rather than using the data as it is and breaking it down at the number of rows directly, you sort it first as per cluster numbers, and then break it after defined rows at a particular cluster number. So either 943 2 goes or 943 goes. There is no in between here. You are not breaking this. This will help us take care of this risk. We will be able to eliminate both problem of memory as well as this isolation, creation of isolation clusters because of breaking them. This will help us understand how these skills are aligned with the rules. Now, how does this solve it? How do we solve the problem here? What's the takeaway? Created that entire model into a function that can be called within an API. And let's say a random user who is interested in a role as Java developer is looking at the job board, and his search of Java developer gives him this dataset where he can see that Java is the most essential skill for Java developer, followed by these. They also need microservices, and in this order, AWS, Kafka, and there are 10% of job listings that still require them to have CSS and SQL as well. So for a Java developer, SQL and CSS are both equally weighted. So what's the takeaway from this as a user? Let's say you do not know AWS. So having some essential knowledge of AWS can actually boost your chances of being a desirable candidate for a given role, where you are actually targeting a role as Java developer. Similarly, there's another candidate, let's say project manager. Now, if we pass project manager here, we see that PMP is a required skill which is above agile, and then project managers need to have a knowledge of Jiva as well as MS project management. This gives me an insight that currently market is moving towards more towards Jiva rather than MS project, as a little over 10% or close to 10% jobs describe Jiva, whereas less than 10, close to 8% jobs need MS project. It could be a chance that these 8% records are required within this as well. That could also be a possibility. This very clearly identifies that change management is not prioritized for a project manager role compared to project planning. So if you are missing some skills on a resume, this tells you which ones are to be prioritized first. There's another way to get more insights on this, that is by looking at the skills. Let's take the example of the same Java developer. If he passes the skill as a Java, then we are able to see that what are the possible roles the market is currently in need of where Java as a skill is valued. Those names include Java full stack developer, Java technical lead, senior Java developer. There's a chance you may only be looking at something called as Java developer or Java lead and missing out on other roles which are more in number, such as Java full stack developer. Roles are more in the market compared to Java developer for a skill Java as primary skill. Then the other way to take benefit of this is a person who has not entered into the market is about to enter into the market. Let's say he's in the construction field or civil engineering field. So search by skill such as construction opens up the understanding that what are the various roles that are past or that are required by the market with this skill. What could be the various career options? Such a person can go into sales manager under the construction domain, or he could be a civil construction engineer or a relationship manager as well. So somebody who's working as a relationship manager may not have looked at construction as an industry, but our mapping will be able to make these intricacies visible upfront. A simple question is, what is the exact value add we can get by putting these three different insights together? Individually, this project does not help much at a wider range, but real value comes up when already existing data sources or data repositories of jobs, which are essentially the job portals, they start utilizing such a model and are able to figure out and recommend smartly to the candidates, to the employee sorting group, that if you add these skills into a profile, maybe they can recommend a certification or a course or a specific skill, and they can compare that your job profile may get a 8% visibility boost. Or there's another way to tell this, that you are currently looking for project management and people with Jiva knowledge are 4% more hireable than a project manager without Jiva as a skill. So this independently, this project will not be able to give this information because constraints will be on gathering the real-time data. But job portals already have this data, and it will be a huge value add over there. this entire model can be put into a container and deployed over the cloud and then used as an API directly on the job portal. Maybe since our current model uses a very lightweight identifier as a vector solution, so we can even the mobile apps will be able to support this feature. This will help those job portals to stay competitively ahead of their peers. Now, what one more thing can also be done, it can also be extended to the recruiter group, where they can be recommended that for the same job skills, industry standard roles are ABC. The role that you have mentioned is not sought after by the right candidate. So there's a chance that you are missing on the valuable candidate because the name is not aligned with the most of the players in the market. So these are some of the advantages that we can identify by this simple text analytics project. I hope you will be able to figure this out and take benefit. Thank you. See you later.